All right, welcome back. This video is on the 1.5 Ready Go problems. And when you look at it, this is a review of what you've done in the past. You actually did a lot in Math 1 last year, and it's domain and range of functions. So let's do a quick little review here. First, what is a function? A function is a relation or a set of ordered pairs. So when we talk about this, you'll see a set notation. You'll see like a bunch of ordered pairs, okay, like this. Okay, so this is a relation, and within this relation, right, for every input, there will only be one output, okay, for a function. And if you remember in a graph, right, we know it's a function if it passes the vertical line test. So this linear function, right, if we draw all these vertical lines only pass through one, right, point on the graph. If I draw another one like this, right, that is not a function because it does not pass the vertical line test. This vertical line passes these 2 points. So a function, again, is a relation such that for each input, there's exactly one output. And we look to see if the graph passes the vertical line test. Now the domain is a set of inputs, all right, which is the x values, right? So where does the graph exist on the x-axis? And a lot of times you guys probably used set notation where you use like square brackets or used a round bracket and a square bracket and use such things as infinity, negative infinity, and so on, right? But then you have the range, which is a set of output or all the y values. And again, you're still using interval or set notation for that. Okay, so let's look at a couple of these real quick. Determine if the graphs represent a function and then find the domain and range. Right? So anytime we're given a graph to determine if it's a function or not, we're going to look to see if it passes the vertical line test. Right? And if I look, is there any vertical line that we draw here that goes through the graph more than once? No. Each of these lines only intersect the graph at one point, and there's no line you can draw that would cross the graph more than once. Therefore, this is a function. Okay, this passes the vertical line test. Now, when we look at the domain, right, the domain is if we were to walk along, right, this graph, if we were to walk it, right, what are all of the x values that would be on it? And if I look, this is a closed dot. So this is the furthest to the left an x value will go, right? And this ordered pair is at -4, right? 1, 2, 3, 4. -4, 1, 2, 3, 4, 5, 6, 7, 8. So -4, -8. And this graph will continue going to the right all the way to here and stop there at, that's 8, -2. So now when we go to find the domain, right, this domain, since this point is solid, we're going to use a square bracket. Where does it start at the x values on the left? At -4. And it covers every x value all the way through +8. Now the range, okay, what's the lowest y value on the graph? Well, if I look at it, the lowest y value is at -8. Since it's a solid point, we're going to use a square bracket. And then where's the highest point? That's up here. And what is that highest y value going to be? At +8. And since it's included in the graph, we're going to use a square bracket. When we look at the next one, you see this arrow here? All right. That means it continues going in this direction forever and ever. So it's going to go down to the left forever and ever. So if we trace this graph here, all right, will this pass the vertical line test? And the answer is yes. This will pass the vertical line test, so it is a function. And when we talk about the x values, it goes down to the left forever and ever. So is there an exact, right, x value that this, starts at on the left? No. So since it goes to negative infinity, right, on the left side, we're going to say it's a round bracket. It starts at negative infinity, and it will go all the way over and stop at this x value of 4. Since it's a solid dot, we're going to go a square bracket. Remember, anytime we use infinity, right, we use a round bracket. Okay, for the range, since this goes down forever and ever and ever, right, that means it's going to start at negative infinity. And if we trace it all the way to the highest point it reaches on the y-axis is 3. And since it's included, it's going to be a square bracket. Okay, so the next one, right, would this graph represent a function? And if I draw this vertical line here, right, this vertical line crosses the graph at this point and this point. Since this line crosses the graph at 2 different points, right, this does not pass the vertical line test, therefore it is not a function. Now, generally, we don't go and find the domain and range, but I want you guys to get practice with this. So let's look at this and say, if I were to find the domain, where does this graph start on the left side? Well, if I look, it starts at this point on the left, right, which is at an x value of negative 5. Since it's included, we're going to go square bracket. And where does it go to the right? Since this arrow points to the right, that tells me it's going to go forever and ever and ever in this direction. Therefore, it's going to go to positive infinity, and it's going to be a round bracket. Now, the range, however, right, if I look at this arrow, it's going to go down and to the right forever and ever. This one's going to go up and to the right forever and ever. Therefore, since this is going down forever, this is going up forever, we're going to say the domain starts at negative infinity and will go all the way to positive infinity. Okay. So example 2 here, now we're given a table, right? How do we recognize if it's a function in a table? Well, the first thing we do is we look at the x values and we identify if there's any repeating x values. Okay. And if I look here, you have 3 repeats here. Okay, so you have 3 repeats here and 3 repeats here. So actually, let me just get rid of all of this. Right, and here's what I'll do. Right, if I look at my x values, I see there's a repeating, right, 3 here and a 3 here. Do these two inputs, right, this is the same input, do they have the same output or different outputs? These are different outputs. So this repeating x value tells me for every input, right, the input 3 has 2 different outputs, which means it's not a function. Okay, however, in the next example, right, if I look at my x values, are there any repeating x values? No. So it's basically telling me for every input there's exactly 1 output. Therefore, this is a function. When we go to identify the domain, right, it's a set of x values. So we make these little squiggly bars, and I'm not doing a good job right now, right? But we make this little squiggly bar, and we say it's going to be 2, 4, 6, 8, 10, and 12. Right? That would be your domain, the set of x values. The range, right, would be the 3, 5, 7. Since it repeats, that's okay, because the outputs can repeat, the inputs cannot, right? And then 9 and 11. You don't have to write the repeating outputs twice. Okay? Now the next one, if I look at each of the inputs, 2, 6, 10, 14. Do any of my x values or inputs repeat? No. Therefore, this is a function. right? And my domain is a set of x values. So what are my x values in each of these ordered pairs? 2, 6, 10, and 14. Then my range is a set of y values, right? My y values are 4, 8, 12, and 16. Okay, so this domain and range idea, along with function, is very, very, very important. So please make sure you understand it. Have a good day.